Write secure Apex controllers. Learning objectives. After completing this unit, you'll be able to describe why sharing rules are crucial in Apex, enforce sharing rules, explain how to protect against create, read, update, and delete (CRUD) and field-level security (FLS) violations. Apex security and sharing. When you use Apex, the security of your code is critical. By default, Apex class's code executes in system mode and has the ability to read and update all data within an organization. Therefore, you must enforce sharing rules, set object and field permissions, and protect against CRUD and FLS violations. You will need to determine which code should be run as system mode, that is, with access privileges to many resources, and which code should be run as user node, in which the permissions, field-level security, and sharing rules of the current user are enforced.
Enforcing sharing rules. Developers who use Apex need to ensure they don't inadvertently expose sensitive data that would normally be hidden from users by user permissions, field-level security, or organization-wide defaults. Apex generally runs in system context. In system context, Apex code has access to all objects and fields. Object permissions, field-level security, and sharing rules aren't applied for the current user. This strategy ensures that code doesn't fail to run because of hidden fields or objects for a user. However, sharing rules aren't always bypassed. The class must be declared using the without sharing keyword to ensure that sharing rules are not enforced. Usually, system context provides the correct behavior for system-level operations, such as triggers and web services that need access to all data in an organization. However, you can also specify that particular Apex classes should enforce the sharing rules that apply to the current user. There are 3 keywords to remember for sharing rules. You use the with sharing or without sharing keywords on a class to specify whether sharing rules must be enforced. You use the inherited sharing keyword on an Apex class to run the class in the sharing mode of the class that called it. The only exception to how Apex runs in system context is Apex code executed with the execute anonymous call and chatter in Apex. The execute anonymous call always executes using the full permissions of the current user.
With sharing. The with sharing keyword lets you specify that the sharing rules for the current user are enforced for the class. You have to explicitly opt into this keyword for the class, as a blank sharing clause on a class means that sharing settings are inherited from the caller, which may or may not enforce sharing. Without sharing. You use the without sharing keywords when declaring a class to ensure that the sharing rules for the current user are not enforced. For example, you can explicitly turn off sharing rule enforcement when a class is called from another class that is declared using with sharing. Inherited sharing. An Apex class without an explicit sharing declaration has an unknown enforcement of sharing rules, as it depends on the sharing enforcement of the caller. Indeterminate sharing enforcement is a security anti-pattern and should be avoided if at all possible. Designing Apex classes that can run in either with sharing or without sharing mode at runtime is an advanced technique. Such a technique can be difficult to distinguish from one where a specific sharing declaration is accidentally omitted. An explicit inherited sharing declaration clarifies the intent, avoiding ambiguity arising from an omitted declaration or false positives from security analysis tooling. Using inherited sharing enables you to pass AppExchange security review and ensure that your privileged Apex code is not used unexpectedly or insecurely. An Apex class with inherited sharing runs as with sharing when used as an Aura component controller, a Visual Force controller, an Apex REST service, any other entry point to an Apex transaction.
Note: be aware that the sharing setting of the class where the method is defined is applied, not of the class where the method is called. This means that if a method is defined in a class declared with sharing is called by a class declared without sharing, the method executes with enforcing sharing rules. Class-level security is always still necessary. In addition, all Salesforce Object Query Language, or SOQL, or Salesforce Object Search Language, or SOSL, queries that use Pricebook2 ignore the with sharing keyword. All Pricebook records are returned, regardless of the applied sharing rules. Enforcing the current user's sharing rules can impact SOQL and SOSL queries. a query may return fewer rows than it would operating in system context. Data manipulation language, or DML, operations. An operation may fail because the current user does not have the correct permissions. For example, if the user specifies a foreign key value that exists in the organization, but which the current user does not have access to. Enforcing object and field permissions. User mode operations. Data operations, SOQL, DML, and SOSL, in Apex run in system mode by default and have full CRUD access to all objects and fields in general. In spring 2023, Apex introduced new access levels allowing developers to select the mode for executing data operations. User mode, system mode. Executing data operations in user mode ensures that sharing rules, CRUD, and FLS permissions are respected and enforced.
Access records in user mode. Access records in user mode ensures the enforcement of sharing rules, CRUD/FLS, and restriction rules. By utilizing SOQL queries with the user mode keyword, such as in this example, select ID from account with user mode. System mode privileges are temporarily dropped, ensuring retrieval of only the records accessible to the user. System mode resumes after the query execution is complete. Insert records in user mode. In user mode, insert records ensures that the insert operation executes only if the user has permission for both creating a new record and edit permission on the field opportunity.amount, FLS check. For example, the user intends to create an opportunity with a value of $500 in the amount field. To ensure that the insert operation proceeds only if the user possesses the necessary permissions to create a new record and edit the opportunity.amount field level security check, follow this approach when writing the code. Another way to execute user mode operations. Update records in user mode. To update records in user mode. SOSL in user mode. To execute SOSL in user mode. User mode operation is the recommended way to avoid sharing, CRUD, and FLS violations. Using with security enforced, you can integrate the with security enforced clause into your SOQL select queries within Apex code to validate field and object level security permissions automatically. This functionality extends to subqueries and cross-object relationships, streamlining query operations and technical intricacies. Created for Apex developers, especially those less experienced in security development, it's a valuable tool for applications where permission errors can be avoided. Here's how to use with security enforced. Strategic placement. Insert the clause after the where clause if present, or after the from clause if no where clause exists. Place it before order by, limit, offset, or aggregate function clauses. For example, select ID, select last name from contacts from account where name like Acme with security enforced. Returns ID and last name for the Acme account entry if the user has field access for last name. Polymorphic lookup fields. Traversal of a polymorphic fields relationship is not supported, except for owner, created by, and last modified by fields. Avoid type of expressions. Type of expressions with an else clause in queries with security enforced is not a supported API version requirement. Use API version 48.0 or later for AppExchange security review when implementing with security enforced. If referenced fields or objects are inaccessible to the user, with security enforced throws a system.query exception, ensuring data security. Using CRUD FLS check methods. You can also enforce object-level and field-level permissions in your code by explicitly calling the sObjectDescribeResult methods of schema.describeSObjectResult and the fieldDescribeResult methods of schema.describeFieldResult that check the current user's access permission levels. In this way, you can verify if the current user has the necessary permission, and only if they do, can you perform a specific DML operation or query. For example, you can call the isAccessible, isCreatable, or isUpdatable methods of schema.describeSObjectResult to verify whether the current user has read, create, or update access to an sObject, respectively. Similarly, schema.describeFieldResult exposes these access control methods that you can call
to check the current user's read, create, or update access for a field. In addition, you can call the isDeletable method provided by schema.describeSObjectResult to check if the current user has permission to delete a specific SObject. Depending on how your custom applications render and process data, unauthorized users can access and modify data that they shouldn't if the code is running in a system context. Luckily, the platform makes it easy to prevent unauthorized access. Let's walk through the DescribeSObjectResult class helper functions that you can use to verify a user's level of access. These include isCreatable, isAccessible, isUpdatable, isDeletable.
IsCreatable. Before your code inserts a record in the database, you have to check that the logged-in user has both edit permission on the field and create permission on the object. You can check both permissions by using the isCreatable method on the particular object. Suppose the user needs to create an opportunity with $500 in the amount field. To ensure that the user calling the function has the authorization to create opportunities and opportunity amounts, your Apex code should perform a check to see if the user has the create permission on isCreatable permission on opportunity.amount. Here's how you write the code. IsAccessible. Before your code retrieves a field from an object, you want to verify that the logged-in user has permission to access the field by using the isAccessible method on the particular object. Suppose the user wants to access the expected revenue field in an opportunity. Your Apex code should check if the user has edit permission on isAccessible permission on opportunity.expectedRevenue. This is how you would write the code to do this. IsUpdatable. Similarly, before your code updates a record, you have to check if the logged-in user has edit permission for the field and the object. You can check for both permissions by using the isUpdatable method on the particular object. Suppose the user wants to update an opportunity to mark the stage as closed won. Your Apex code should then check if the user has the create permission on isUpdatable permission on opportunity.stageName. Let's check out how this looks.
IsDeletable. Lastly, to enforce delete access restrictions, use the isDeletable function before your code performs a delete database operation. Here's how to configure this operation. Notice that unlike update, create, and access, with delete, we explicitly perform only a CRUD check, verifying that the user can delete the object. Since you delete entire records in SOQL and don't delete fields, you need to check only the user's CRUD access to the object. Using strip inaccessible. You use the strip inaccessible method to enforce field and object-level data protection. This method can be used to strip the fields and relationship fields from query and subquery results that the user can't access. The method can also be used to remove inaccessible SObject fields before DML operations to avoid exceptions, and to sanitize SObjects that have been deserialized from an untrusted source. You access field and object-level data protection through the security and SObject access decision classes. The access check is based on the field-level permission of the current user in the context of the specified operation: create, read, update, or delete. The strip inaccessible method checks the source records for fields that don't meet field-level security checks for the current user. The method also checks the source records for lookup or master detail relationship fields to which the current user doesn't have access. The method creates a return list of SObjects that is identical to the source records, except that the fields that are inaccessible to the current user are removed. The SObjects returned by the getRecords method contain records in the same order as the SObjects in the source records parameter of the strip inaccessible method. Fields that aren't queried are nil in the return list without causing an exception.
Note, the ID field is never stripped by the strip inaccessible method to avoid issues when performing DML on the result. To identify inaccessible fields that were removed, you can use the isSet method. For example, the return list contains the contact object, and the custom field socialsecurity_number.c is inaccessible to the user. Because this custom field fails the field-level access check, the field is not set, and isSet returns false. This is how it looks. Note, the strip inaccessible method doesn't support aggregate result SObject. If the source records are of aggregate result SObject type, an exception is thrown. Now that you understand how to run Apex in user mode,
enforce sharing rules, and protect against CRUD and FLS, you can secure your Apex code. Next, we look at how to protect against injection vulnerabilities.